All right, so I decided we can go ahead and do number 16 now. I've got a golf ball being hit from the ground, going straight up 6 seconds and coming back down. This is the same as our tennis ball lab, actually, but I chose a golf ball so that there's no confusion about that I hit it from a meter up high or something like that. It left the ground, it came back to the ground, makes things a little easier. The event starts as soon as it leaves the golf club. It ends right before it hits the ground, so it's always in the air, it's always in free fall. So we have the acceleration downward the entire time of 9.8. And you notice I asked us to use 9.8 this time. I know I use 10 most of the time, but I'm going to go ahead and use 9.8 this time, as you can see in the calculations. And I can go ahead and change that to a 9.8. So when we have acceleration downwards, we realize that the velocity might be positive or negative, even though the acceleration is always negative. So here I am, I'm on my way up, my velocity is positive going up, but my acceleration is downward. On the way back down, I've got velocity negative, and the acceleration is also negative, so it's speeding up on the way down. We choose to have the initial situation be at the bottom and the final be at the top. And that's nice because then we can know our VF. Our VF is 0 in that situation. Notice we cut the time, which was 6 seconds, in half. So we have 3 seconds here. And again, our acceleration is negative 9.8. We know 3 things, so we can solve. Looks like it's real easy to just go ahead and get VI. So I plug in VF is 0, A is negative 9.8, T is 3. And I can solve and get my initial velocity is upwards 29.4. And if you were doing this with 10, you'd get a 30 there instead. In any case, now that we have VI, we can run to this equation, and this will allow us to get the displacement, the vertical displacement. So we go ahead and we put in 3 seconds for time. And you don't want to get confused and accidentally put in the 6 seconds. It's half the time, so we're putting 3 in there. This 3 squared gives us 9. And don't forget your negative on your acceleration, and you'll get 44 meters high. That's because 6 seconds is a long time. We hit that ball pretty high. I also asked you to draw the graphs. So here's our acceleration axis. This is time axis. And our acceleration, sure enough, is negative the entire time. Whether it's going up or going down, the acceleration is down the whole time. The velocity is 0 at the top. That represents this location right here. This is when it's high. This represents when it's down by the ground and it's moving upward very fast. This represents right before it hits the ground. It's moving downwards very fast. So you'll notice on velocity graphs that when we're close to the time axis, we're moving slow. And when we're far away, we're moving fast. Okay? This is our position, and even though this looks like maybe the ball went sideways, this axis here is time. So the ball actually went straight up, came straight back down, and we're just showing how high it went over time, and we have a nice parabola there. And that is number 16. Let me know if you need some other help. Thanks.